Hello, engineers. Welcome to Uhandisi Talks. My name is Marian Golda, as usual. I'm your host here to Uhandisi Talks. I'm the founder of Uhandisi Talks and also a civil engineer. I practice as a civil engineer. I'm so excited to be here today, having a session with Joram, an agricultural and biosystems engineer. With me is also Angela. Um, she's going to introduce herself and she's going to be a co host today. So, today we're having the Engineer Spotlight series, the very first of this series starting today. And what we are doing is we're trying to build visibility for engineers and to have us network with one another, to know what you're doing, to learn from each other, share knowledge. As we all know, one DC Talks, the purpose is to inform, to mentor, and to build engineers. So without further ado, I'm going to welcome my co-host to introduce herself briefly, and then we're gonna get right to Joram. Angela, we can't hear you. You're muted.
Hello engineers, my name is Angela Mora. I volunteer at Uhandisi Talks. Thank you.
Fantastic. Thank you so much, Angela. So, Joram,
Yes,
welcome to NDC Talks.
thank you, thank you.
So we're gonna have you introduce yourself a bit. I know you're an agricultural and biosystems engineer, um, but we need to know, we need to hear from you. That I also know that you've started a company, but I want it to come from you. I don't want to water down anything. So please, could you just tell us about Joram, what you do, your professional background?
Okay, thank you so much. First of all, I would like to start with appreciating that this good initiative you've started. It's really important for us all to connect as engineers because actually it's civil engineering that is commonly known in the society. And so these are big steps we have here. So to start, my name is Joram Mochiemo. Yeah, an agricultural and biosystem engineer. And my specialization is in the area of soil, water, and environmental engineering. So
Okay.
here where my interest lies in dealing with irrigation systems, drainage design systems, structures, especially those related with farm utilities. That is what that's where my interest grew while I was studying agriculture and biosystem engineering. And in this course, I think I've recently graduated. That is about 7 months ago. That's when I graduated. Yeah,
Okay.
and I've gotten an opportunity to work with the Ministry of Water and Sanitation. That's where I got this interest. I developed the interest in this field. And having an opportunity to work in different projects like dam design, irrigation implementation. Yeah, those are the areas that I've worked so far. And from then onwards, I've born this idea of having a company and serving the community from my own capacity. That is where I
Mhm.
developed my interest in having a company, and we started a company with my friends that is called Big Pharma. Actually, we started as an irrigation company, but now we have diversified to other structures in agriculture and
Okay.
design the designs in agriculture. Yeah.
Fantastic. So that's actually a fantastic background. In considering that you just graduated 7 months ago, I think you've done so much.
Thanks.
Congratulations. I want to ask you about your interest to do biosystems and agricultural engineering started. And just take us way back before you go to campus. Because I have to tell you myself, when I when I went to study civil engineering. As much as I thought, as much as it's widely known, and I thought that I knew what it is about, I actually had no idea. I came to understand that it's just so wide and it's beyond roads and buildings as people know it. So how was that? How was that experience for you? How did you come to learn of this biosystems and agricultural engineering before campus now, and where did that interest start at that point?
I think it is the gossips that gave me that. It wasn't something on my interest. Neither did I hear of agriculture and biosystem engineering to begin with.
Okay.
My interest was in civil engineering, actually. That is what was my dream course.
Okay.
Unfortunately, I had to pick between a university, it was JQuat, whether I
Mm-hmm.
should go to JQuat or another university with a lower cluster point. So I wouldn't say that I was so inspired or had a lot of interest in doing agriculture and biosystem engineering. It was just a matter of chance that it happened so. But along the way, the first year, as I learned about what the course is about, that is when my interest started growing in it and realizing the value that course has to the society. That sparked something in me. And yeah, that's how I think it is for me.
You know, that's so interesting, Joram, because you and I have the same story. Kinda. Because personally, I actually wanted to do electrical engineering, and it's until I went to first year that I really understood civil and what it entails, and I developed the interest then after starting my studies. So we kind of have the same story about how we got to do the courses that we are doing. And we're going to talk about what you've said. You went to first year, that's when you learned what agricultural and biosystems engineering is. And in a moment, you're going to tell us what it is, because we also don't know. We don't know. Agricultural engineering, I mean, tunalima or what? We don't know. So we want you to tell we want you to tell us what um what um what agricultural and biosystems engineering entails. What is it when you went and started your studies in your classes? Now that you have the understanding, you graduated. What does agricultural and biosystems engineering really entail?
Yeah, that's a very good question, and I think this is a question. If you ask most biosystem engineers, it's a question they will always want to avoid.
Okay.
When because even for me personally, when I start out, or maybe I'm in a new environment, and you think you'll burden someone with telling them about this big word biosystem agriculture and biosystem engineer, what is that? So that course yenyewe to scare people away, but
Mm-hmm.
uh, so biosystem and agriculture and biosystem engineering,
Mm-hmm.
it has three mm, three aspects that we look at, and as a whole, to look from it from a bigger scope, is that agriculture combines the agricultural part, scientific agricultural part, and we have the engineering principles, basic engineering principles. I guess this is always common for the first and second year for all engineering schools. That is to consider the uh, designs, things to do with the drawing and design, things to do with mathematics and calculus. So those are the basic principles that are centered around all engineering principles. So for agriculture and biosystem engineering, the second part that comes in is now the production part
Mm-hmm.
of materials from the farm, and the last part is now post harvest handling of materials from the farm. And now in between, we'll also have the machines that do that work. And then there is also another side of that. The other side is now where we have soil, water, and other resources used in the farm to help to facilitate in production of these materials. So we have the machinery bit and we have the environmental part of it. In other campuses they call it environmental engineering or biosystem engineering, just that. So as a whole, it combines scientific agricultural knowledge and engineering knowledge together to come up with solutions that solve problems that arise in the agricultural sector.
Okay. Okay. So that's agricultural.
Yes.
Do we have biosystems in there as well?
Yes, it's
Can
biosystem
we
comes.
uh-huh. Please go
uh,
on.
Biosystem comes in when you talk of a farm as the system, bio and the system. When in
Mm,
every sector, maybe in every production sector, it's a system.
yeah.
So
Okay. Yeah.
we have it as biosystem because it deals with biological products.
Okay. Okay. So that is okay. Everything sounds like Greek to me. I'm sorry, but I'm sure the agricultural and biosystems engineers will understand, and that's the point. Um, so what's coming to my head right now is, when you look at engineering, it's about solving a problem. You
Yeah.
design a solution to a problem in the society. So
Mhm.
I'm trying to think, what is this point? What is this? What is which problem are now biosystems and agricultural engineers coming in to solve in the society?
Okay. Yeah. When I was introduced to this course, I think as you learn, you get to pick a specific point that you'll work on. So I'll just
Mm,
mention the where these agriculture and biosystem engineers fit and where I am for me personally, where I serve as an agricultural and biosystem engineer. So, I, first of all, agricultural and biosystem engineer can work as a processing engineer in
mhm,
factories that deal with production of food materials, me- medicine, and also we can have this the other materials that are made whose raw materials are plants and animal products. That is one
okay.
area they work, and they are known as biosystem or biomechanical engineers. That's after
Mhm,
they have specialized. Another area they can work as agricultural. Now this I refer to this now agricultural engineering because we are focused in the much of the field work going
mhm,
out in the farms. So they
mhm,
do the designs of maybe irrigation systems.
mhm,
They also design the farm structures. You can talk of the huge greenhouses that you can't just do it them in a very conventional and getting a fundi and help you do that because
mhm,
the aspects of design and structure that you need on that. And another
mhm.
thing for them to manage projects, they are projects that when given to just a normal engineer, maybe now a civil engineer, there are aspects of agriculture that are involved that
Mhm.
a civil or engineer needs that knowledge in agriculture to make the right decision on it. So that's when he can consult an agricultural engineer, or even maybe there are projects like dams. Now, when
Yeah.
you are doing a dam, there are dams classified according to the purpose they'll serve in a given area. So there are
Okay.
irrigation dams to be specific. So the conveyance of that water to that specific dam, now that engineer plays that role, but as a water engineer.
Okay.
Yes.
Okay. So I'm hearing designing like greenhouse spaces. I'm hearing designing what production of medicine, which was very shocking. And there's something you mentioned, production of plant-based what? What was
Uh,
it?
Plant-based materials whose raw materials are plants.
Is that for construction?
Not really. They are to serve other purposes, like maybe materials. Which can I give an example? biomaterials, a good example is maybe we hi it's something we come across every day now. Huh. How do you call this? There are packaging bags that can be made from, maybe you can have sisal used on that. So there are those
Mm,
machines that can be used in making those materials. And when I talk about medicine, I'm not talking in the space that they are now assessing what the quality or what should be done for that and specific product to be what it should be. But what I mean when I talk about production in the medicine space is that those machineries used in that industry, they have to understand how those systems and the operations of those systems are to be designed to ensure that they meet the standards to produce what is required.
okay. Okay, now I'm starting to see the problem solving coming out. Yeah. And okay, as we proceed, we're going to talk about, of course, food security because you talk of greenhouses and large scale. I don't know if the farming is large scale, but I'm going to give Angela now an opportunity to now um, guide the discussion towards you coming up with this uh, organization, Big Pharma, as a very young engineer. So Angela will guide the discussion on how that started, and you're gonna tell us the whole story. And I've had very big words on your LinkedIn like hydroponics. I'm like, what are these? You tell us more about that, Angela. Angela, you're muted. Please take us through now the big pharma.
Um,
You're still muted, Angela. You're still muted.
Sorry. About big pharma, if some people when they name things, the name comes from something, or it has a deeper meaning behind it. So, is there a deeper meaning behind the name big pharma?
Yes, actually, it has. From the name Big Pharma, in fact, when you hear the name Big Pharma itself, we all know of this Big Pharma that is a pharmaceutical company that runs the world. So, in the picture that it is displayed right now, we see Big Pharma as some industry that is there to oppress, and maybe they are making profit out of people's miseries. So, for me, I said in the farming sector, we can have a kind big farmer, a farmer whose interest is to make sure that we get the right medicines, which are food. If you, they say that if you don't eat your, if you don't eat right, you'll take your medicine as food. So for me, I felt that that was one of the things that led me give branding it big pharma. And also another thing was to look at the farmers. They are small scale farmers who are not looked at. And from that, I realized that big pharma, we will identify ourselves with these small farmers and labeling them as big pharma because 80% of the world's food production comes from small scale farmers. And ironically, I think those are the big farmers that we have because they produce 80% of the world's food. So our focus as a company is to help improve the ability or the economic status of these small farmers who are big farmers in a different way in what they contribute to the society.
Thank you so much. And that's nice. That's actually nice. Big pharma, big farmers, and yeah, that's nice. Could you please share your journey with Big Pharma and what motivated you and your friends to start Big Pharma?
This goes back to last year around the same time. I think we were also having some lecturer strike that was going on in the country. So around that time, I had tried farming now, not as a professional, but now you just going to the farm as a farmer and trying out things. You see where you will you get when you do those things. So what I did, we were in the farm and then just following the conventional ways of farming, and of course, uh, we made a lot of losses, big one, of course, and it was a learning for me. We had done some cucumber. It was cucumber that was in the farm, almost an acre. And the first things you have to know is that the investment you put into farming, I didn't realize it's that much until you get to do that. So I thought it was that simple, just buying the seeds, getting them to the farm, finding the right fertilizer, and waiting for your harvest and finding the market. So that is how far my knowledge was in terms of farming was concerned. I just left my knowledge, my theoretical knowledge in class, and now practiced the way the other people do in the farm. So as we were doing this in the farm, something happened. Like one day, about 2 months after now doing all the activities, checking after the plants, you come and realize that, well, everything has just dried out. It is so unexplainable the way it happened, because everything was very green in the moment and the rain is there, but kumbe it was about the diseases that come to the plants. So from then onwards, I just decided, I said, maybe agriculture is something that doesn't have much uh, return, and it requires a lot to do it. So where is the avenue for me to make money? That was the intention for me. Where can I make money through this course now? So I thought of it. Number one, there are problems in agriculture. One of them was how you get your water to the farm. Another one was how much land someone needs. You need a lot of land to get more produce and produce more so that you can make more money. But then that is where I drew my lines. One problem was to get the water to those people, to farmers in a very better efficient way, and number two was to increase produce from a very small scale piece of land. So that is when I started trying out these things to do with irrigation systems, drip systems, because by the way, drip saves a lot of water. Almost 80% of your cost that you can use in that is saved. And from that, I think is when I realized, well, it's something that can be turned into a business. And it's not that it's an invention or something that is coming up for the first time. Other people have done it. And for me, I saw it, why, well, other people are doing it. Why can I not also join them in doing it? Because the industry is so underserviced, and we can help in contributing to changing the lives of many farmers by solving their problems.
That's actually that's nice, and congratulations. I think you're doing a lot. Um, and when it comes to how big pharma impacts small scale farmers and food security in your country, how do you envision it impacting small scale farmers and food security in our country?
Okay. One of the things that Big Pharma is focused on, and it's the one thing that we started out with, was hydroponics. Just the way she said, she would want to know about hydroponics. So in hydroponics, it's a type of soilless farming whereby you are not relying on soil as a medium of production of plant production. So when you do some little digging, you'll realize that plants use the soil as a medium to hold the plant on the ground so that it can as a means of support, and it also provides some nutrients which nowadays you can buy them at the shop. You can get them, you can prepare them by yourself and make solutions for them. I mean liquid solutions, that is what I mean for that. So having those hydroponic towers, we'll have towers and also trays that can be used to produce that uh, to produce that can be used in making the farms efficient. So a farmer, we were doing some calculations first. So we produce a tower. A tower can have 44 plants, and in a 1 meter square space, you can have maybe in a farm. That's to give a real example. In a farm, in a 1 meter square space, you'll have around nine, at most nine plants. That is when you observe the intervals required for planting. So that requires you to use a lot of space. So when you have that, one tower can have 44 plants. And 44 plants in a 1 meter square, that is almost 9 times the whole what you can do in a 1 meter square. So if farmers, even a farmer with a quarter an acre of land, can produce much more and serve a market with just that small space of land. So when we introduce this technology to the farmers, we are actually improving the food supply within our country and food sovereignty. By the way, at the core of Big Pharma, one thing I was about is food sovereignty. I'm so big on geopolitics to do with food sovereignty and things to do with how the external forces control us through the policies and what we have to do in order to control us. So one of the things that is important for a nation is is food sovereignty. That ability for us ourselves to choose what we can plant, to choose what we can eat, and to choose what we will not eat or what we will take. But now, as Kenya actually imports food from different countries right now. There are even in. I was surprised during COVID that we was importing wheat from Ukraine. We still do, and Ukraine at that time was in COVID, and then it was having war with Russia, but we still did import food from them. So when we rely on foreign aid or foreign imports of food, it we have limited choices of what we can get ourselves. But when we have that within our borders, we have enough supply within our borders. First of all, it will improve the economic stability of our country. It will also help us as a nation to create meaningful jobs for those people at the lower level of the society. Maybe they can have something to do as they impact others. uh, that is one of the things I think when I talk of food sovereignty is what is comes to mind. That ability of we as a community or a nation to be able to produce our own food and not rely on foreign aid.
Okay. With your permission, Angela, if I can just ask a question that has just come to my mind. Before you proceed, I was thinking because you're saying now, with this model, I'm seeing you see the city set up the way it is, and the apartments the way they look like. And I wanted you to tell us if you have a solution for that kind of a setup, because that's majorly why I think we we have this we consume everything and we produce nothing. So I'd like you to address that if you have solutions for that. Number two, You were telling us of this hydroponics being a situation where you are growing food, but you really don't need the soil, so you bring in the nutrients some other way. So what came to my mind really, and I think what is going to be on most people's minds, you see, there's always this mentality with anything that is manufactured that is coming to your body. There's always a mentality that it is not healthy for consumption. So you see people advocating for natural, natural fertilizers, something that is grown on soil, like it's it's imagined to be more healthy than when you bring now the artificial fertilizers and whatnot. So, have you gotten such kinds of concerns? Getting the soil out of the equation and now bringing the manufactured nutrients and everything to food productions. Is there a health risk at all in there? Is there anything people need to be concerned about? So those two things, please.
Okay. I'll start with the first one about in the urban setups now. What can we do because we consume and we are not producing? Yeah, actually, in urban setups, it's a bit of a problem. And what we are doing, we are trying to make small hydroponic towers for those spaces, for hydroponic, for the urban spaces, maybe the balconies, those who have small spaces as kitchen gardens. So that is what we are doing. And that is not specifically meant for any type of commercial production or large scale production. It's just for that home use consumption, especially with something to do with vegetables, those short perennial crops that grow. That is what we focus on as Big Pharma. And that's the reason why we do that is because when you look at the content of the or the origin, when you try to do some research on the maybe vegetables that you get from the market compared to that which you'll get from a place, from that source, maybe it's a farm, buy, or that even that hydroponic tower you have in your place. If you have that knowledge of where that is coming from, I think that is a bit important, because now you've also pointed out something which is very important, that it always comes across. People always ask about this. When something is not uh, from the soil, it is considered not natural, maybe. And what they refer to it as is mostly they can't understand, but anything that is not conventional, they can label it as GMO. And
Exactly.
so that is what happens. But for us, what we happen to use is the synthetic fertilizer on that point. Actually, recently we had a client who challenged us a lot, and I think we are looking onto that. He wanted us to do organic production. I mean, we use organic fertilizer on these hydroponic towers, and it's a test that we are doing. Of course,
Okay.
it's important first to consider soil as a medium of production, because the biggest benefit you will get from the soil is that the biodiversity of it's what gives it the organic value that we as consumers want. When you see something grown in the soil, not only do you get that nutritional value from it, but having a wide biodiversity of nutrients that you'll get from the soil is what matters. That is why it is considered better to have. That is why most people consider it better than the hydroponic part. For this synthetic fertilizer that is used in hydroponic systems, uh, that solution has two things in it. They are very specific. That is where we do precision agriculture. I mean, when you give the plant what it needs at that time, and that is what is usually done in the hospitals. There are those times that a patient cannot be able to eat well, like
Yeah.
uh, he cannot eat to obtain the required nutrients in his body. So there are medicines that they are given to that specific, to serve a specific role. So
Yeah.
hydroponic systems work in such a way whereby they only give the plant what they need. And one of the shocking news that happened when it was noted in the Business Daily, the amount of lead content and heavy metals that is found in the vegetables in our markets in Nairobi was
Mm.
very shocking. And it when they say uh, vegetables are the leading cause of cancer in the city, that was very ironical. I couldn't understand how that happens, but it's because of this high heavy metal content in the plants. And looking at how that happens is because of water being used in irrigation. The water used to irrigate those kind of plants. Maybe it's waste from industries. That
Yeah.
water has a solution of heavy metals. That is what
Mm-hmm.
happens. And lastly, I think for the benefit you'll get from this hydroponic system is because that it we only give the plant what is supposed to have so that it can grow and be nutritious to you.
That's a fantastic solution. You know, I think until recently I hadn't thought of that, and I just wonder people who are like me. I think earlier this year I had visited a friend in Nairobi, and they were so passionate about agriculture. You know, also in my mind, I would never connect agriculture with the city. You'd always connect agriculture with the rural areas because you wouldn't imagine how the two would even go together. So I think I can only imagine if every family in the city is able to produce their own vegetables, and how that can be um, uh, can turn around everything in terms of health, mostly in terms of health, and also having the choice to choose what to eat. And also, I think about how when you go back home, they don't really struggle a lot because they grow their food, you know? So money, they don't really have to have money all the time. They will always be eating. Food is always there. So I think this is a very important thing and an important area to focus in the society. Thank you for answering the questions. Back to you, Angela.
Okay, thank you so much. You've talked, okay, in Big Pharma, do you guys, okay, the projects you guys do, are there any projects you look at them and say, this was a really challenging project? And did you learn from the challenging projects, or, yeah, did you learn from them? Was there something you worked on and said, oh, I didn't know this? Was there something you were told to work on and then you said, you need to do a little bit of research, and then in the process you learned new things?
Yes. That I can say. I can share something on that. Uh, I've been involved in three different projects. One was consulting, and the other two were implementation projects. So I'll just talk of these two to be specific, that involved provision of solution and consulting. So it is a farm that was being developed. Someone was developing a farm for agri-tours. So he wants to put a farm, and that farm was supposed to have a reservoir. It was also supposed to have to draw that water from it was close to a river, first of all. So he needs water to get to that reservoir first, and also the water supply to the whole farm. It has different sections where he has demo farms for different crops that are in that farm, and also another one to serve the animals within that farm. So we wanted an improvement so that maybe people can go there, can visit and pay a visit, and then they pay something. So that's I don't know that type of business how they usually call it, but it's agri to us to me. So in that farm, my what we were assigned as big farmer was to come up with a very effective solution to get the water from the river. And that to me seemed quite simple. It was quite a simple thing to do, but now the challenge comes in with you wanting to satisfy the client's interests. So number one, he told me that these were the parameters he gave me. Number one, you should have that system must use the least energy possible. It must be cheap, and must be it must give us it must serve the demand of water in that farm. And when you look at that, the demand of water in that farm was around 10 meter cubic per day. That is a to me, that was a big demand to solve with a less energy efficient pump, and also without using much money to get that. So the solutions I offered, number one was to use a solar pump. But the problem was these clients wanted to use the least amount of money as possible. You know how a business person can be at times. He really emphasized on that. And so we had to go for a different solution. And those were the hydrants, and also there are DIY pumps that can be done. So those were the projects we came about. So we had to design that hands-on, and that was quite a challenge. It worked only for a short was needed, but for small amounts it can serve. So the challenge there was the demand, what the client wants and what the reality is. So having the two converge is a bit of a challenge to have them. The second client we had was someone whose land was being destroyed. Uh, I think the recent rains were eating up his farm through erosion. So a large portion of his land was washed away, and he wanted some land restoration in his area. So the challenge there was how he had directed the water to run through his farm. And so you realize that where the water was going to is where the problem was. So it did affect that place. And for us as clients, as big pharma, what we did was to give. We didn't have the resources to do the actual work, but for the consultancy, what we gave was how to redesign that water conveyance throughout the farm up to the drainage point. And one of the biggest challenge I would say, having started out, is that every day you are learning something new, and there's no project I've done. The three, they are never the same. They can never be the same thing. That you can do this thing today, use that knowledge here, and then you go use it in another project. You just learn each and every day you come across a project. And a bit theoretical knowledge is important, but there's that aspect of you thinking on your feet, knowing what you should do at that moment. So there are things that I think schools should also employ to help us as engineers when we get out here.
I'd like to interrupt again, Angela, because the last statement, you can't believe how many people relate to it. The shock when you finished school, and actually wanted to ask you if some of the things you did in school you apply when you do consulting. Do you apply some of the things you did in school when you do consulting? Like what percentage of it? And what do you think should be incorporated in the curriculums as well to help with that transition to the job market?
I think, yes, I use some of it, maybe 10%. There are some units I think they have a lot of weight. Uh, even though we didn't consider them to have much value then. These units about engineering in society, there are other units in project management. You see, they are light units that for us, we considered calculus and
Mm-hmm.
those heavy mathematics units as the most important. Those are the ones to give you the skills to work as an engineer. But as an engineer, I think, especially in project management, dealing with people is the biggest task that you have. You can know everything, you even know this is the right thing to do, but the people who you deal with, they don't understand that. They just
Yes.
want things to be done the way they know they are. So yes, I think maybe also about the transition, you can come up on the last part you asked about transition to the job market.
Yeah. You want me to repeat the question?
Yeah, the last part you were asking about.
Oh, because you're telling me like there's some things that you felt like should have been integrated in school to help you better. You know that what I mean by transition is you finish school and you need to start working. So
Uh-huh.
you see, you come out and you think everything is going to work out because you've been learning for 4 or 5 years. But then you realize that and what you were saying about every project being different, you need to apply your mind to get the correct solution for every client and things like that. So what I was trying to ask is some of the things that you felt were useful to you during that transition to the job market. What you thought it was, how you thought it was supposed to be, and some of the things that you had to change maybe so that it can be a bit more seamless.
Okay, okay. So one thing when I was getting out of school, one thing I was thinking, especially when I was working in the first project, number one, what I thought was, because I have that knowledge in doing a specific task, or that knowledge as an engineer to handle a specific task, that is what should happen, and that is what my client should listen to. But that is not what happens. You have to, it's the other way around now.
Yeah.
Solutions are not like, you don't get what is given to you in class is not the final solution. You are, I think it's a roadmap they are pointing out to you, but we were not told that, like, you as an engineer, when you get out there, you have to, this is not the final thing, that this is not all the knowledge that you will have so that you can do work out there. It's
Yes.
just something that they have to prepare you to be open minded and to be ready to continuously solve problems. That is what I
Hmm.
think engineers should be prepared for. Every time once they get out of school, they should have that mentality that, well, solving problems doesn't end at this point. That is just the beginning of solving problems.
Okay. And something else that I also had in mind, Joram, is um, the business aspect. You know, just listening to what you've been talking about and how you actually went and did literal farming. You know, before you start providing solutions and you're wondering why they're not listening to you. I was so impressed that you actually went and farmed and you saw the problems that the farmers, your clients face. And I think that even helped you to know when you come in to give them the solutions, you actually have the experience. Um, what I wanted to ask in connection with that is the business aspect of it, because not everybody has the mind to actually leverage the engineering knowledge they have to make money outside of um, employment, of being employed. So this, okay, the business, like the business side of how's been your experience using your engineering knowledge to come up with a business. some of the challenges you faced starting this business? Is it something that is doable and that people can actually just, you know, they can just try it, like they have it as an option. You know, when you finish school, you have starting your business as an option. It's never an option. It's always a plan B kinda. Most people it's a plan B, like they may cost a job, so maybe try starting a business somewhere, something like that. It's never part of the plan. So I want you to talk to shed more light on that, please.
Okay. That part of business, I think most of it came from a different light. Uh, First of all, it's possible. Number one, it's very doable for any engineering course. You can just start a business on it. But now I can't give you like a framework. Like now, as an engineer, you are doing this course, you can do a business in this space. So yeah, one thing I realized that is that business in itself is just a different space. You see, and it's something that is should be integrated in every course that we have in our universities right now. It shouldn't just be like now when you are going to study business, you are going to study it just business. When someone is doing engineering, just focus on engineering. Someone
Yeah.
else doing a different thing, just focus on that. So to me, one thing I'll also say is that I feel like I should have taken a course in business when I was in campus, and that is one thing I think would have helped a lot. So for someone who's starting out, me, this is one thing that helped me. It was a lecturer who actually inspired me to do this. He
Okay.
told me, right now, to be realistic, if I tell you about the job market, there are jobs, but you have to do a lot of work in it. And then, so I said, what is the other option? He told me, Do your own business." Then I thought, this could be a simple option. So he said, but the bottom line was this line, and I'll always remember this. He said, if your degree cannot make you work, make that degree work for you. If you can't, it
Wow.
cannot make you work, you can make it work for you. So that knowledge, you can't pick everything in your course to start a business.
Mhm.
And how, I don't know how to be delicate. It's a very delicate matter when you talk about business and your engineering course. One thing I'll say, I don't know how passion lies, because there are many. When you start a business, passion and money are different things. When you are after
Yes.
making money because we want to survive first of all before having our passion, there are two different things. So you can find your strength in that. There are many units you've covered in school, and you can realize, well, this is what I'm good at. And looking at how other the industry operates out there, just go and do some research on how does this serve, or does this contribute to the industry, and then see what problem does it solve. Or you can just start by working for some engineering firm, some, I don't know how I can put it, just a business, any business, regardless, and then see what can be applied in this that we have learned in class. That is the simplest answer I can give.
Okay. Okay. There is something I was still taking in, but it just slipped my mind. But it's fine. I'll get it. So I think we almost coming to an end of this conversation, and I just feel like we've just hit the tip of the iceberg. I have a feeling you're gonna come back here, Joram. So back to you, Angela. Maybe you can ask the last two or three questions, and then we can conclude.
My last, I think, two questions. The first question is, what advice would you give engineers, especially engineers in your field who are going to graduate soon, or the ones who are still trying to find what engineering field they should enroll in, like which course or something. I don't know. I'm not an engineer, so I don't know these things. But what advice would you give them, like when it comes to choosing which field they should venture in and stuff like that?
I First of all, I feel like this question needs someone older than me, someone who is as so that it can have more weight when you give advice. Because now, so this is what I'll tell them as my peers. I'll just tell them just to be open-minded, and the one thing that is holding us back is fear, like that fear to try something out. That is what holds us back, and having that uh, picture that once I'm out of school, this is where I'm supposed to be as an engineer. Maybe in a big organization, I have to fit. There are good stories, by the way, of someone who just finished his engineering course. He got a scholarship, go to a certain university, maybe job or an internship role somewhere. So there are very different things that happen. And also, one challenge that comes up is that when you talk about the fear, is these people. I'm talking from what I experienced earlier. Now you've finished engineering school. People have high expectations from you, and by them having high expectations from you, you can't just take any job to start with. You say, Nasiwi, this guy just did engineering. How comes he's the one? Maybe you are serving as as a receptionist somewhere. Then,
Mhm.
oh, that is something that, like, let it not lower your self image or self esteem in a way, because I mean that ego that comes with your engineering uh, course or achievement, let
Yeah.
it not be an hindrance for you to seek opportunities or to take any opportunity. Yeah.
That's actually good. I am out of questions. This is a good talk. Thank you so much, Joram.
Thank
You're
you,
welcome.
Angela. Thank you for helping me. And thank you so much, Joram, for being here. Personally, very motivated, I have to tell you, to try out. There is no actually, it's either it works out or it doesn't work out. It's someone say it's either you succeed or you learn. So I think we as engineers should try out a bit more of things that we have or in our minds or our passions. Just try it out and see what happens. It's been a very interesting conversation, and it's been very lovely to have you here, Joram. So before we close, maybe you can tell us how to connect with you.
Okay, thank you. To connect with me, I'm very active in LinkedIn. You can connect with me at Mochiemo Joram. The rest of the platforms are not very active, but in my WhatsApp, yeah. Can I share my number here, or it's
Yes, if you're okay with that.
okay? Yeah, you can get me through LinkedIn. That's where and my email is at mochiemojoram@gmail.com. That's where you can find me. And at Big Pharma, you can also find us at info@bigpharma.co.ke. Yeah, you can check out our website there and services. Yeah, we'll respond to you. Thank you. Actually, I'm so impressed with what you are doing here. This is actually I've never been to this session such as one,
Okay.
so I'm learning something from here.
Karibu
how,
sana.
how someone should be prepared. And one thing I'll say is that, to be honest, this is a good initiative. We have many engineering organizations, but just to identify that, to acknowledge what engineers do is what is missing. we just have them. We just have engineers association something, but
Mm.
acknowledging what is being done is not happening. So thank you for this. I'm so grateful and happy for the opportunity.
Karibu sana sana sana, and I'm convinced you're going to be back here, Joram, because you've not finished.
No,
So thank you so much to our viewers. Thank you so much for joining us here on DC Talks. As always, we are here to inform, to mentor, and to build engineers. Bye bye. Till next time.
bye.